Broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we've initiated a series of webinars conducted by industry speakers to give you all a crisp insight of various domains. The topic of today's session is Roadmap to Continuous Delivery. Our guest speaker today is Vivek Boge. He's a senior architect at Sears Holdings Corporation. Vivek is having over 16 years of experience in building, designing, architecting complex enterprise solutions used by millions of users worldwide. He is currently working as a senior architect on e-commerce lines of product in the integrated retail space. He is a technology and lean process evangelist for best tools and practices across organizations. He enjoys working closely with the developers and designers to enable and empower them with best tools, practices, and patterns for solutions. When he's not brainstorming with the team or laying technology roadmap of the products or not contributing to the online tech forums, he likes to escape to new places and indulge in creative activities like photography and videography. When indoors, he enjoys playing with latest gadgets and solving puzzles and riddles with his kids. So without further delay, I introduce you all to our guest speaker. Over to you, Vivek.
Thank you, Deepika, and hello everybody, and welcome to this webinar on Roadmap to Continuous Delivery. So we hope you all can see this slide. So we are just about to launch this wonderful and exciting presentation with a very interesting topic. And we'll walk through what is continuous delivery and we'll discuss the agenda in a little bit. But before that, I hope you had a wonderful and exciting start of the week on Monday. And one of the things that we are going to learn in this course of this webinar is how to make your Mondays exciting, delightful, and stress-free. And not only Mondays, but each day at the work. All right, so let's start now. All right, here is the agenda for this webinar. Firstly, we'll define what is continuous delivery. Then we'll speak a little bit about the origin of continuous delivery and how it has evolved over the time. And then we'll discuss what are the key pillars or the key aspects that go into making continuous delivery a success. Then we will have a pictorial representation of a typical deployment CD pipeline. And then we'll delve deep into what all tools are required and what all infrastructure is required to implement continuous delivery. Next, we will emphasize on the quality aspect. And finally, we'll see what are the key benefits of implementing continuous delivery and who all stakeholders really care about that or are benefited directly because of implementing this process. So in a nutshell, we'll try to answer three key questions. What is continuous delivery, how it can be implemented, and why organizations really need to implement continuous delivery. So all right, so let's start with the what question. So, there are three key terms that are used, and many times they are used interchangeably. So we would like to expand on that. The first is continuous integration. So basically, continuous integration is the process in which every developer checks in or commits his code changes as soon as possible to the code repository. So basically, all the changes of all the developers are getting merged into the source code repository in a continuous fashion. So developers do not really sit on their code changes for days or sometimes weeks, but they deliver or they integrate their changes continuously with all the other changes from the other developers. The next is continuous delivery. So what it means is that the integrated code and configurations are actually deployed on a server. It could be like a QA server or a staging server in a continuous fashion. So what it means is that all the changes of the developers are not only buildable, but they are also deployable. And there are a lot more details associated with each of these phases, and we will discuss in detail in a little bit about it. But for now, and the last and the final is continuous deployment. So what it means is that you are actually able to deploy to your production and make it available to your end users or the customers, right? So in continuous delivery, what you're saying is that whatever code changes have happened are actually, deployable to production, but you're not necessarily deploying it actually to production, but the continuous deployment is the ultimate goal and ultimate objective of this process, wherein you are actually able to deploy your changes in a seamless manner with a push of a button to your end users or your customers. So here you can see a formal Wikipedia definition of continuous delivery, which I'll read it for you, is a design practice used in software development to automate and improve the process of software delivery, right? So to expand it a little bit more, like, we have various phases in the software development life cycle, like define, discover, design, develop, and deploy. Similarly, for continuous delivery, we have three different stages. The first is continuous integration, followed by continuous delivery, followed by continuous deployment. Now let's look at the history of where this concept has come from and how it has evolved over the time. So way back in 1994, Grady Puch was the first one who referred to this term, or who coined this term, continuous integration, in his book Object-Oriented Analysis and Design of Software. And followed by 1997, Kent Beck came with the concept of extreme programming. And one of the key drivers of making extreme programming successful was continuous integration or continuous delivery. Well, it is debatable, the success, how much this extreme programming was successful, but nevertheless, continuous delivery was adapted regardless of extreme programming. So the organizations which did not adopt extreme programming, they were actually all for continuous delivery as a separate, concept or a separate philosophy. So so obviously, continuous delivery is about automating various stages in your delivery cycle. So obviously, you will need a great tool to enable you to do that. And in 2001, ThoughtWorks came up with the solution, a software product named Cruise Control, to enable and implement continuous delivery. In 2005, the open source community came up with another solution, open source solution, uh, named Hudson, and basically, a few years later, when Oracle acquired Sun, the Hudson community had some conflicts with Oracle, and they decided to go independent, and they named this as Jenkins. So Jenkins is like, initially it was a forked out Hudson, but now it is an independent organization, and lately it has become a professional organization, and the latest offering or the latest flavor of Jenkins is called as Cloud-based, and it has all the bells and whistles that are required to implement continuous delivery in enterprise. Moving on, the next key question is that now that we know what is this philosophy, the next key question is that how do you really go about implementing it in your team, in your project, or in your organization? And before that, or it's like, before building, constructing a building, you need to have some key pillars, right? And similarly, we will see what are the key pillars that go into implementing this process. The first and the foremost is continuous integration and automation. Automation is the key. So what it means is that the developers are expected to commit their changes to the main line continuously, check in daily or more often if required, but typically at least once in a day. And then you need to automate the builds and keep them really fast so that there is less turnaround time. And if there is any issue with the build, then the developer gets the immediate feedback. A typical way to do that would be, use build tools like Ant and Maven. We will also discuss more about the specific tools that go into this. But for now, what is expected is that every developer's code commit has to be built, and that too automatically, giving feedback to the developer and all the other stakeholders in case of build failures. Also, because we are really talking about delivering the code changes into production, one of the most important aspects is quality. So we have to ensure that all the changes done by the developer and going out of the door to the customer, they are of very good quality, of production grade quality. And hence we have to implement all the checks and balances for the quality, to ensure the quality at every step in this whole workflow or life cycle. So what it means is that every time a developer checks in his code, it has to automatically trigger some code quality tools that will give the metrics. That way we know whether the changes are really production grade and whether they are actually deployable to the production. The other thing is that the database and other configurations need to be as close as production. So probably you have heard about this term or heard about a typical case where you see an issue in production, but the developers are denying, saying that we never saw this issue and we have tested this scenario. And one of the main reasons for this particular scenario is because generally the database is not exactly like production. So which means that your data is not very valid and live data. Also another key thing over here is that there has to be a minimal manual intervention. So we'll actually look at the pictorial representation and then you'll understand more about what I'm actually saying. But in this entire workflow, there has to be a minimal manual intervention. Everyone needs to happen at the push of a button ideally. Moving on, the next key pillar, and which we discussed a little bit earlier, is the code quality and the different checks and balances that can go into ensuring the good code quality is the static analysis, unit testing, code reviews, and ensuring that all of this is done properly. So again, when it comes to code review, one other debatable topic over here is whether it has to be a pre-commit code review or post-commit code review. Each one has its advantages, but a general standard, industry standard, is to go with the post-commit code reviews. Next is build quality. So the build that is deployed on the, let's say, QA server has to undergo all the automation tests like smoke tests and regression tests to ensure that the functionality is working correctly and there's no regression. One other aspect I would stress over here is that one thing is about automating your test suites by using something like Selenium, TestNG, or JBehave, but also you have to be very careful about the quality of your automation. So typically what I have seen is that the QA team thinks that it is a very good automation suite, and let's say they are covering 90% or 95% of automation. But this percentage is really very, very relative, because what they are saying generally is that 90% or 95% of the total number of test cases are automated. But that is not sufficient. We also need to see, or we need to check whether those automation suites are actually touching all your flows, hitting all your flows in the code. And one way to ensure that is to actually find out the code coverage of your automation. That way you will know, if there are any classes or if there are any methods that are not being hit by the automation. And that way you can improve the quality of the automation. And next is the actual pictorial logical deployment representation of a typical continuous delivery pipeline. So on the left hand side, we'll start with the first phase in this workflow, which is the coding step. So let's say a developer is doing some code changes, and the purple box out here is the scope of what the developer is expected to do in this particular phase. So the developer has to ensure that he has various tools in his development environment that will help him to ensure the quality of the code. And the different aspects of this quality at this particular stage is, to the bare minimal, the coding style, the static analysis, unit testing to ensure that functional flows are working fine. And then once the developer is happy and satisfied with this particular aspects or processes, then he checks in the code. Now the code review over here is indicated after the code check-in, because over here we are talking about the post-commit code review. Now let's say during the code review, if he's got a feedback about changing his changes, or changing his code further, then he needs to fix those things and again run the static analysis, again run unit tests, and then check in the code or commit the code to the source code repository. Now you see the Jenkins tool, which is actually controlling all your different phases like dev testing, QA testing, stress testing, and pre-prod or staging, right? So what it means that the Jenkins has all the build scripts which are integrated and which will actually do all this work in an automated way at the push of a button, and sometimes actually at every code check-in. So in this workflow, what we have seen is the developer has committed his code, and because Jenkins is actually listening to the repository, it, for every code commit, it actually triggers bunch of steps. Like the first step over here on the dev server is that it builds, the code along with the configuration. And in the course of building, it also runs static analysis, and it could run your JUnits again and give out the code coverage, and deploy and post deploy it will run all your functional automation of the black box automation tests. Now one thing to note over here is that initially the developer has done few of these steps, but then again Jenkins is triggering the same steps like the static analysis and the code coverage, right? Even on the dev server. Now dev server is separate from the development environment which the developer was working earlier. So in the dev server, we are actually running all these steps again, because over here we have the integrated changes from all the developers, right? So, but when the developer was testing, mostly it was not completely integrated with all the other changes that were happening at the same time. So over here, what we are ensuring is that whatever build is coming out of the latest changes on the dev server is actually of good quality. Now, just to elaborate more on static analysis, it is one of the very important step. That's because it catches majority of your coding issues upfront. Now those coding issues could be simple things like catching null pointer exceptions, or if there are any connection and other resource leaks, or whether there is a compliance issue like from security perspective, and there are lots of other things, right? I mean, typically there are like 400 checkers in a typical static analysis tool. We'll talk about the tools more just in a little bit. Alright, so what we have said is that Jenkins has built the code on the dev server, and it has run all the quality checks and balances, as well as deployed the changes and run your TestNG automation. Now let's say at this point it checks whether it has passed all your criteria. Like for example, all the test cases, automation test cases are passed, or let's say if your code coverage threshold is let's say 90%, then it has ensured that the code coverage remains at 90%. In case of any of the violation, what it would do is it will go to the just look at the decision box, and it will go back, and if it has not passed, it will trigger an email to all the stakeholders, and then the developer has to again go and fix the breakages and so on and so forth, and then deliver the code again. Now one thing to notice over here is that as soon as the developer has committed his changes, in no time, probably in an hour or so, he has immediately got the feedback about how his changes look in the entire integrated environment. So that way, earlier we talked about stress-free life and peace of mind. So at the end of the day, the developer is ensured that whatever check-ins that he has done, they actually conform and they pass all the quality criteria, and as well as it has not broken any functionality. Now let's assume that on the dev server, the dev server step is passed. So now what Jenkins will do is Jenkins will deploy the same on the QA server. Now one question that could arise over here is that, because we have run the automation and the other steps on dev server, why do we really need to do it again on the QA server? Now there are a couple of reasons to do that. One is that, the dev server step needs to be very fast. And because we want to give the feedback to the developer as soon as possible. Whereas on QA server, we can run more automation. So for example, we can run the entire regression suite here, which could take, let's say, 3-4 hours, right? And then, like if the latest features are not yet automated, then the QA can actually decide to run some manual tests. And also, it is desirable that they work on automating the latest feature. And also, we have to check the code coverage of the TestNG or the functional automation over here. So assuming that this step is also passed, the next step in this workflow is to do a bunch of performance tests and load tests, and that Jenkins deploys the changes or the build on the stress server, and then triggers some bunch of performance and load test scenarios and decides whether it passes or fails. So let's assume that it passes. So the next step is to actually deploy the build on the pre-prod or the pre-production server, also called a staging server. Now one difference between the staging server and the other like QA server is that the staging server is very, very close to production. You should have a Jenkins job which typically copies your production data, and then if there are any security concerns, then it basically encrypts few of the things and populates the staging database with this relevant data. So once the staging step is passed, then you know that you're all good to go to live to production. So the next step in this cycle and the final one is to deploy the build on production server. Now let's say you have multiple servers or a cluster of multiple nodes in the production like we have typically. Then you want to really deploy the build on the production without causing any downtime, and that is where rolling deployment is very, very important in this stage, wherein each node is taken out of rotation and then upgraded with the latest build and then again put back on rotation. That way it is very transparent to your customers that a release is happening right now. Now moving on to the Jenkins view that depicts the various build pipelines or the continuous delivery pipelines over here. So you could have multiple pipelines, each pipeline associated with, let's say, one project or one branch, and then in this pipeline view, it actually highlights all the steps in the course of the continuous delivery, and it highlights them with various colors to indicate where the pipeline is at what stage currently. This is a very, very important dashboard, because all the stakeholders can actually look at this and know what is going on. So for example, the developer can see that his build has passed and the acceptance tests have passed, for example. Similarly, your product management or the business can see then what all features are going in which particular build, and then where they can have a look at those features that they are interested in. All right, so moving on. Now we looked at the diagrammatic representation of the continuous delivery pipeline implementation, and what we saw is lots of processes at every step. And on this slide, we look at the recommended tools to implement each of these processes or each of those steps. So we have three dimensions, typically three dimensions: development, quality assurance, and the operations. Now, looking at the first dimension, we have various processes that we briefly touched upon in the earlier slide, like static analysis, code coverage, code style, and the code reviews, unit testing, etc. Now, on the right-hand side, I have listed some recommended tools based on my experience with these tools to implement these processes. Most of these are open source tools. So, for example, the recommended tool for static analysis is are like Fineworks and PMD, which can be used as Eclipse plugin in the development environment, and SonarQube, which is a continuous quality inspection server. So, and it is very central to the ecosystem of continuous delivery. So what it means is that once the code from a developer is integrated or delivered to the code repository, then you can have a build that triggers all these static analysis and other quality processes, and actually store the quality metrics at a central place, so that you can anytime go and look at the SonarQube, and you can also look at the history and the trends, the quality trends. The next one is Cobertura, which is a great tool to get the code coverage of your unit tests as well as of your functional tests. Other alternate tool is Emma, and it is more of your preference, but I have listed Cobertura over here, which has few more features and it's more active. The development is more active. And then you could use check style for your coding style. It doesn't catch a lot of real issues, but from maintainability perspective, it ensures that the coding is done in a proper format and a proper style, and it is consistent across the development team. Next is code review. Code review is very important, and there are a bunch of tools. Many of them are open source, and what I have recommended over here is a review board. You can get more details at reviewboard.org. This is a open source tool again, and one of the reasons why I have recommended it over here is because it pretty much works with all the source code control systems, right from your, SVN, Git, your CVS, ClearCase, all, Visual Source Safe, all of them. But let's say if you are using Git, then another recommended tool for Git is Gerrit. But one downside of Gerrit is it only works with Git. Now JUnit, as I'm sure all of you know, is the best tool for developer unit testing, so that before committing the code changes, they can actually do some white boxing on the code. And I also listed about Javadoc and the project management, although we did not see that in the CD pipeline, is because like the SonarQube tool also runs these tests of how well documented is your code, and also your Jenkins CD pipeline can actually integrate with your project management tool, so that all the features that are going into a particular build are tagged or highlighted, and that way the product management and the business will know what all features are going and in which branch and will be deployed where and what is the status. The next dimension is the testing or the quality assurance, and then all these familiar tools I'm sure you already know, which is the TestNG, WebDriver, and the Jira for defect tracking, and again JMeter is an open source for load testing. And one good thing is it can actually be integrated with your Jenkins lifecycle. LoadRunner is a paid tool, obviously, but I have put it here because that has like more features, and you could still do a final one test using LoadRunner or any other competing tool, performance testing tool. But at the Jenkins level, we can use JMeter for initial performance testing. And obviously, this whole picture is not complete, and the foundation is the continuous integration tool Jenkins over here. Now post the production, it's recommended to use a few performance monitoring tools, so that if there are any violations of the defined thresholds in terms of, let's say, page load time or response time or etc., then you are immediately alerted. So moving on. Now again and again we are focusing on quality because that is the key pillar in continuous delivery. Because you're really talking about your code changes flowing into the production, every day or several times in a week or more often. You really have to ensure that the changes are of the highest quality. And who cares about the quality? Obviously, customers care about the quality. And the business, because it saves money, it is always cheaper to fix the issues very early in the cycle. And also they are happy because customers are happy. And finally, the development team, which is working on the ground in delivering these changes, because it directly impacts their productivity. Nobody wants to do rework, right? They want to do it right the very first time. And all these processes ensure that. So I have also defined quality because it's a very relative term, but finally what it boils down is the user satisfaction levels or your customer satisfaction levels. The next one is again emphasis on quality, and this particular slide is shows the total cost of ownership of software. What you can see over here is that majority of the cost is incurred in the maintenance phase. So it is good to have a very good quality software so that it is very easy to maintain. It has fewer issues. Moving on, now this particular slide speaks about how do you really map all the processes that you are using towards gaining perfection in continuous delivery process, or let's say it is a benchmark about where your team is in the continuous delivery maturity model. So it is something like a CMM or something like a DevOps maturity model, which tells based on different criteria, it tells you where you are in that process or maturing that process in your organization. Again, we have like 4 maturity levels here, and this one is something that I worked with internally here at CS, and we came up with this after a lot of brainstorming. And it really helps to tell you, like let's say, let's look at the quality assurance or the QA dimension. It tells you whether you're at level 1, 2, 3, or 4. The ultimate objective is to go to level 4. And if you're talking about a push button deployment to production, then you must be at level 4 in this maturity model. Now the million-dollar question: why do we need continuous delivery? Who cares about it? Does it really add value? And you can see that these are the key benefits of continuous delivery philosophy, right? So the first one is time to market, which means that you can actually get the latest and the greatest features out of the door to your customers in the shortest possible time. Now, also what it means is that because your features are directly accessible to your customers, you'll get early feedback. Unlike the big bang releases, right? I mean, few years back, many organizations and probably few organizations today as well, they had big bang releases, like 6-month release or 1-year release, and wait a minute, 10 more days to cut your DVDs with some nice artwork and shipping it to the customer. But now with the internet, the whole paradigm is changed, and you can get your features to the customers as soon as you are ready with those. So the next one is quality. Again, because quality is a very integral process of CD, you ensure that your software is of good quality. Productivity, because there's very less or no rework. Developers immediately get the feedback of quality of their deliverables. They are using various tools and processes so that they catch any quality issues early, and that way they do not have to rework, and that increases their productivity. You don't want half of your team on support, right, and fixing issues in production, chasing issues in production, and that is where the quality and the productivity are so interrelated. Next is the winner, the most important winner in this whole ecosystem is the customer. Is very happy. It doesn't have to wait until next month to access that feature that he loves so much and has been waiting for, and he can give feedback, and then you can do incremental releases because you don't have to wait until you complete all 10 features. As soon as one feature is ready, then you can get it out to the customer. And obviously, what all of it boils down to is profitability of your organization, because you have happy customers, you have more productive development teams, and So that's why you will have a more profitable organization over here. All right, so we are done with all the benefits of continuous delivery, and this is pretty much the final slide, and we will try to solve a jigsaw puzzle over here regarding how all the stakeholders interpret or benefit from continuous delivery. The first one is, like we discussed, customer. He can access the features early. The business, because they can try out new features and get it immediately to the customers to get the early feedbacks. And also the conversion of the features, meaning which features are really the customers are liking and can get them more customers and delight the customers. The product owner or the product manager, because he is delivering on time, frequently, consistently. The delivery manager, because his team is not delivering on time again and quickly. QA team, because now they are not dependent on manual tests and they are not worried about missing any critical test cases, and they are not doing the same mundane jobs over and over again. Rather, automation is taking care of most of the testing, and they are busy automating the next features or coming up with some innovative ideas that can better the QA process. And finally, the developer, and we discussed already that developer is also very happy because he does not have to do, or she does not have to do, rework. And the developer can have peace of mind at the end of the day because the developer knows that whatever changes were delivered are of good quality, they have not broken any integration, and all the automation is good, which means that they can really be very stress-free and do not have to worry after going from work whether how the changes will gel well with the other changes and whether it will work, whether it will cause any regression. So all in all, everyone is happy. And this brings us to the end of this presentation. And we can...
Yeah, thanks, Vivek.
Yeah.
Thank you so much, Vivek, for the insightful presentation. Let's now quickly take up the questions. I would request you to read out the questions and their answers so that all our users may listen to the commendable insights.
Yeah, sure. All right, so I'll quickly go over. We have quite a few questions over here. The first question is, which artifact will be getting deployed on QA or prod? So the answer to this is that the code changes or the configuration changes or your DB scripts, all of this will be deployed on your QA or prod. So basically, Jenkins internally uses, let's say, Maven to build, and then it copies all your artifacts. They could be, let's say, WAR files into the QA or the production, so that it can continue with the next steps in the life cycle. And a related question to this is that, what is the plan B? As in, like, what is the plan to, let's say, if in case the deployment fails, then how does the Jenkins actually, and how can you revert to the next, good state? And obviously, in the in the Jenkins script, you can always use the pass-fail criteria and decide. So, for example, typically, let's say a smoke suite or a sanity suite, which covers the very basic functionality. If that fails, then you can actually, script the, in your Jenkins in such a way that it reverts back or rolls back to the previous good build. But if there are any minor breakages, you would still want to go ahead with the deployment and build and automation. And you would still want to give a feedback to the stakeholders so that appropriate JIRAs could be created and tracked. The next question over here is what do you think about Bamboo? Yes, so Bamboo is also a good CI server, and I have used it in the past, maybe about before for 5 years. And there's no one size that fits all. So you get the philosophy from the presentation or this webinar, and you get all the various aspects and requirements to implement a good CD pipeline, and you can always use the competing or alternate tools for each of those phases. The next one is so whether manual or test automation, which is better to perform the test on application or project? So obviously, automation is better, and nobody wants to run the same manual mundane task or mundane test every time. And then there is always a risk, because it is manual, there's a risk that you may probably miss something, and it is not really a very productive task or which brings a lot of value. About the non-automatable test case, yes, there could be some scenarios which is nearly impossible to automate. And in that case, like we saw in the diagram, the transition from one phase to another, let's say from QA to staging, can always be manual if you want, and if you know that there are some manual tests that need to be carried out. So you have to see the cost-benefit analysis of everything that you do, right? So for example, automating a particular test case, if it is going to take a whole lot of efforts and the cost-benefit is less, then yes, for those selective scenarios, you could go with the manual test case. All right, so the next question is that how to cover any store procedure related code in the code coverage. Yes, so for example, like we have JUnit for Java, there are other frameworks like DBUnit, which will take care of your DB store procedures. The next question is for CD, should the project always contain or unit test cases? It is very highly recommended because that is first entry point of the developer when they are actually testing it for the first time as they are developing it. And what it also ensures is that the contract between the various classes or the method is maintained, and that way it does not cause the breakages or it does not impact the integration. Also, from the testing perspective, right, unit testing is very, very productive, because it's very easy to test or check all the boundary conditions. Think about it. If there are, let's say, 7 boundary conditions of a method, for a method, and you want to test it once that change goes into QA, the QA will have to come with 7 different test cases using your Selenium TestNG UI. And think about the number of methods, number of classes that you may have. So, and that is the reason why unit testing is very useful and effective way to catch issues early in the cycle. The next one is I'm just scrolling through the questions, a bunch of them. The next one is, if I am using Maven release plugin, so for the development it will be snapshot, and as per the CI it will be committing the changes to the SVN. So as per industry standard, the production artifact should be specific version. And what in case if I want to roll back my changes back to the previous artifact? Now, like we discussed earlier, you will have to customize your Jenkins script and base them on the outcome of your validation checks, and decide, and then write some manual script so that if there is a major breakage, then it rolls back to the previous good version. The next one, and probably the last one, considering the time constraint, is I have to check a lot of Jenkins. Is there any way I can have a consolidated view of all Jenkins dashboard in one view or dashboard? Yes, certainly. Jenkins is very powerful. It is having a lot more ways to customize the dashboard, and a typical way to do that would be to go into my views in Jenkins, and over there you can see the pipeline views, and there are lots of plugins available for Jenkins that can help you integrate the various facets of and that you are interested in, and then actually create a dashboard customized for you. Alright, so with this we will end the question and answer session for this webinar.
Thank you so much, Vivek. I'm really thankful to our guest speaker, Vivek, for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgeek.com very soon. Thank you, everyone. Thank you, Vivek.
Thank you, Deepika, and thank you everyone for your time and joining me in this webinar session. I hope that it was useful to you, and wish you all the success to implement this continuous delivery process in your organization. Thank you and bye.